Good afternoon. In the last lecture, rather in the last week, we saw resistances in series and parallel, mesh analysis and node analysis corresponding to KVL and KCL. So now we will see a step further, which is supermesh analysis and supernode analysis. Again, you have already done this in BEE, so I'll just take one example each and then we'll be done with the lecture, so we can actually start with the new things which you are going to learn in this course. So what we have to do, find the current through 10 ohms resistor for this network. So if you observe, there is a current source and it is between two meshes. So whenever there is a current source lying between two meshes, the mesh is called as a super mesh, and you cannot directly apply KVL to those mesh. So how to go about this? That is the concept of super mesh analysis. So let's directly try to understand this with the help of this numerical. So what is your first step in mesh analysis is always assign the mesh currents. So let's say this is I1, this is I2, this is I3. Then we assign the polarities. So this again is going upwards, so current flows from higher to lower potential. So this is plus, this is minus, and this is plus, this is minus with respect to the first loop. For second mesh, this will be plus minus, this will be plus minus. Similarly for third mesh, this will be plus minus, right? So now we can start applying KVL. So applying KVL to mesh 1. Let's start from here. So what do we get? Plus 2 minus I1 minus 10 times I1 minus I2 equal to 0. So after solving this, what will we get? Minus 11 I1 plus 10 I2 equal to minus 2. So this is our first equation. Again, number of meshes are 3, so we'll require 3 equations. We have got one of the equations. Now what happens if you try to apply KVL here? Here we will get, if you start from here, minus 10 times I2 minus I1 minus 5 I2. But this is minus 4 into what? Because KVL is what? Summation of V plus summation of IR equal to 0. So you have I, you don't know the resistance. You cannot apply KVL here. So KVL method fails here. So this is the concept of supermesh. So we write, since meshes 2 and 3 have a current source in between, they form a super mesh, and therefore we can directly write in this case, what is the current source of value? 4 ampere. So if you observe, I3 is going in the same direction as 4 ampere. So we first write I3. Then if you observe, I2 is going in the opposite direction as I3 as well as 4 ampere. So it is minus I2. And this value will be equal to 4 amperes. So this is directly our second equation. So this becomes simple actually. Next we write, applying KVL to super mesh. Okay, so which is our super mesh? I'll draw with the red sketch pen. This is our super mesh. So we'll apply KVL in this direction. We'll start from here. So what will we get? Minus 10 times I2 minus I1 minus 5 I2 minus 15 times I3 equal to 0. So just solve this. Therefore 10 I1 minus 15 I2 minus 15 I3 equal to 0. This is our third equation. So we have 3 meshes, we have got 3 equations. So the equations we have got, and we have 3 unknowns. So we can completely solve this equation, right? So just take your calci and we can solve this. So what will this be? Minus 11, 10, I3 is 0 here, 0 I3 minus 2. Then I1 is what? 0 I1. So 0, I2 is, remember, minus 1. We have written I3 minus I2. And we require I1, I2, I3. So minus 1 plus 1, 4. Then 10 minus 15 minus 15, 0. So we'll get I1 minus 2.3478 amperes. Since it is negative, we can write it as positive. So 2.3478, and it will be in which direction? Anti-clockwise, because negative it is clockwise amperes. I2 equal to minus 2.7826 amperes. So I3 equal to 2.7826 amperes in the anti-clockwise direction. This is I2, sorry, and I3 equal to 1.2174 amperes, and this is in clockwise direction only because it is positive, right? But this is not our final answer. What we have been asked to find current through 10 ohms resistor. So what will be current through 10 ohms resistor? Where is the 10 ohms resistor? Here. So if you observe, I2 and I1 both are flowing anti-clockwise, right? So I'll use a green pen. So I2 is flowing anti-clockwise, I1 is flowing anti-clockwise. So in this case it is flowing upwards. So now both were opposite in direction. So check which is the higher value. So this is 2.78, 2.34. So what will be the resultant current through I10? It will be I2 minus I1. So current through 10 ohms equal to I2 minus I1. Therefore current through 10 ohms equal to I2 is 2.7826 minus 2.3478, 0.4348. So 0.4348 amperes. And what will be the direction? It will take the direction of higher value current. What is the higher value current? I2. So I2 is flowing downwards, so it will also go downwards. So this is our final answer, and this is how we solve sums on mesh analysis. Okay. So next we use KCL and supernode analysis. So what will be a supernode? What was a supermesh? Meshes 2 and 3 shared a common current source. So in this case, what we can say, meshes nodes will share a common voltage source. There it was a current source, so now they will share a common voltage source. So in this case, determine current in the 5 ohm resistor. The nodes are already given, V1, V2, V3. So if you observe, V2 and V3 are sharing a common voltage source, so they form a supernode, because in this case we cannot apply KCL directly. So let's see how to solve these numericals, right? So what is the first step we do? We assign all the current going away from a particular node. Then we write applying KCL at node 1. So let's start from here. So it will be V1 by 3 plus V1 minus V2 upon 2, and going away from the node, but current is coming towards us. So this will be minus 10 equal to 0, right? Because current is coming in the opposite direction. So you solve this, what will we get? And again collect the terms in V1. So it will be 3 inverse plus 2 inverse. So 5 by 6, which is 0.8333 V1 minus 0.5 V2 equal to 10. So first equation. Again, how many equations we'll have? Equal to the number of nodes. So we require 3 equations. So 2 more equations are remaining. Then same as supermesh, we'll write, since nodes 2 and 3 share a common voltage source, they form a supernode. Okay. So what we can write directly? Let's say current is flowing away from V2. So current is flowing like this. So what will be the equation? It will be V2 minus 20 minus V3 equal to 0. So therefore what we will get? V2 minus V3 equal to 20. Equation number 2. Then writing KCL equation for supernode. What will we get? So 2 and 3 together form a supernode, right? So this is my supernode. So considering this as a supernode, consider currents going away. This is the way we have to solve. So what will we get? V2 minus V1 upon 2 plus V2 upon 1 plus V3 minus 10 upon 5 right here plus V3 upon 2, nothing is remaining, so equal to 0. Therefore, then again solve them. So collect the terms in V1 minus 0.5, that's it. So minus 0.5 V1. Then V2 is 2 inverse plus 1 inverse, that's it. So 3 by 2, which is 1.5. So 1.5 V2. Then 5 inverse plus 2 inverse. So 0.7. So plus 0.7 V3 minus 10 by 5 is minus 2. So equal to 2. This is equation 3. So next what will we write? Solving equations 1, 2 and 3. Therefore, V1 equal to V2 equal to V3 equal to. So let's solve them. So 0.8333 minus 0.5, 10. Then second equation 0 V1 plus V2. So 1 minus V3, so minus 1, then 20. Then minus 0.5, 1.5, 0.7 and 2. So V1 equal to 43.7469 volts. V2 equal to 17.2152 volts. V3 equal to minus 2.7848 volts. This is 4. But what is the question? Determine current in the 5 ohm resistor. So locate the 5 ohms resistor first. This is the 5 ohms resistor. Right? Now how is current flowing? Like this. So current flowing through this is by Ohm's law V by R. So V3 minus 10 upon 5. So current through 5 ohms is V3 minus 10 upon 5. Am I correct? V3 minus 10 upon 5. This is a reference node. So it has a voltage of 0 volts. So therefore, current through 5 ohms equal to V3 minus 10 upon 5. What is V3? Minus 2.7848 minus 10 upon 5. So current through 5 ohms is minus 2.55696 amperes. So if I write in positive, current through 5 ohms equal to 2.55696 amperes. We have taken it downwards, so this will be upwards. So this is our final answer. So this is the way we have to solve some supermesh and supernode analysis. So we'll just revise in 2 minutes. How we came to know this is a supermesh? Because meshes 2 and 3 were sharing a common current source. So this formed a supermesh. So how to write the supermesh equations? First equation we get it directly. I3 minus I2 is 4 amperes. Because this is a current source, we can write in terms of currents only. We just have to check the direction of currents. Next we apply KVL for the supermesh. Which was the supermesh? This was the supermesh. Right? So we applied KVL to that supermesh. This was supermesh analysis. For node analysis, here what was the case? Common current source was shared. So dual KCL is dual of KVL. So here nodes 2 and 3 share a common voltage source. So we assume this direction. So we got V2 minus 20 minus V3 0. If you took this direction in the opposite way, then also you will get the same answer. It will be just negative of this. Next we write we consider 2 and 3 together as one node and apply KCL. Okay, so this is the way you have to solve sums on supermesh and supernode analysis. Now my videos are usually very short, around 20 to 30 minutes only. I am assuming I am giving extra half an hour to you for solving the sums on your notebook. So make sure you solve them. Practice is very essential because many students make silly mistakes. And make sure you use Calci. I am using Calci in front of you. Make sure you also use Calci. Don't be under the impression that I'll solve it in Calci. It is very simple. Most of the mistakes are made in Calci only. This I am telling from experience. So make sure you solve the numericals and use Calci also. Thank you.